Hi, this record is about Archimedes screw, Archimedes conveyor or elevator. I have a short presentation, few slides, just to answer the question saying Archimedes screw or conveyor we mean what, and then, well, in CAD environment in Inventor, I'm going to demonstrate how the main part of such a conveyor or elevator or pump can be created in Inventor environment. Let's start. Yes, Archimedes screw conveyor or Archimedes screw type pump or elevator. Well, in this wallpaper, the model of an Archimedes screw is partially in the display. Yes, the main central part is a cylinder in shape. Around the surface of the cylinder, there is an helical extension. Well, it is just form of a screw, helical screw, but it is not to use for fastening purpose. It is not to assemble one part to the other. It is not to screw into the hole of a nut. It is not a bolt, it is not a cap screw, it is not a stud. It is just the rotor of a pump or conveyor or elevator. Well, here in this cartoon, it is illustrated. Well, the main part of this machine is an Archimedes screw. Yes, there is a cylindrical tube. Okay, well, within the cylinder, this is the Archimedes screw. Okay, this end of this mechanism has been immersed into, well, in the cartoon, maybe sea or lake or well, freshwater reservoir, and then, well, it is driven manually, a person here rotating the rotor. Well, since there is a helical groove around the core of the Archimedes screw, well, it creates a local vacuum at the entrance, and then, well, the fluid particles are captured, and then, well, by force, the threads of this screw pushes the water particles, and then water is by force well, moved from here to there. Okay, using this mechanism, it is possible to convey water from the well to a higher level. Of course, today, well, not manually, but can find in the market the Archimedes pumps or conveyors or elevators. It is driven, the rotor is driven by a motor. Here in this photograph, within this box, yes, the cap has been opened. Well, this is the main part, valuable part. It's an Archimedes screw. And here, this is the driver, electrical motor. It rotates the Archimedes screw. So, well, at this end, the particles are taken away and then move in the direction. Okay? While it is rotating, then, well, rotor can carry fluid particles or can carry the particles of another matter. Well, here the mechanism is horizontally oriented. Okay. Well, the particles, well, depending on the case, may be fed from here, and then, well, the particles are displaced by the effect of the forces applied by the threads of this helical groove, and then particles move in this direction and then leave the region, or vice versa. Okay. It is a conveyor. If the inclination angle of such a mechanism where the main part is an Archimedes screw is horizontal or near to horizontal, then it is said conveyor. It conveys the particles from here to there. But if the inclination is, well, not horizontal, but, well, in the order of acute angle or right angle, then it is mainly called elevator. Especially if the part where we have an Archimedes screw is vertically oriented, it is called elevator, Archimedes elevator. Okay, this is a harvester in this photograph. Harvested, well, wheat particles, okay, while using this mechanism, you see, suck from the field and then, well, conveying to the truck, into the backhoe of the truck. And yes, this is the solid model of such a mechanism. Since it is vertically oriented, yes, particles are taken from here and then, well, by the helical groove, the particles are pushed, moved in the up direction, and then, well, the particles can reach to a higher level, and then they are used over there. Since the inclination is 90 degrees vertical, instead of saying conveyor, we preferably say elevator. Okay. After this short, very brief presentation, just to say what is Archimedes screw and why it is used, then, well, in Inventor, deal with the CAD application part. Well, here, my demonstration, I'm going to create the solid model of the main part. It is Archimedes screw. Okay. Part, it is going to be a single component. Okay. Actually, here, a designer, for instance, Archimedes screw, well, helix angle and the diameter of the helical part, measured diameter, and how many threads will exist from one end to the other end. These are design issues, and the thickness of the thread is also determined by the designer. Okay, designer considers the speed, considers the flow rate. For instance, here, well, depending on the volumetric flow rate it is needed to have, okay, to convey water from here to there. Well, the diameter of the threaded part, and also speed of rotation for the rotor are both determined by the designer. And also the thickness of the thread is determined, okay, by the designer. Designer considers the strength of the material at the root of the well, the screw, this part. Then, well, say something on the thickness, determine the thickness. Considering the shear stress at the root can determine the thickness. Well, in my demonstration, I'm going to say that, well, all of such things have been determined. So, size of the Archimedes screw has been fixed. Okay, and then knowing the determinate values, deal with the rest, how the model is created. Okay, sketching stage. Well, the core part of Archimedes screw in my demonstration, well, going to be, let's say 20 millimeters, or say 30 millimeters. Finish the sketching stage, and then, well, for having the core part, it is in shape a cylinder. Of course, here, if it is going to be used an elevator, Well, what is the distance between the inlet port and the exit port? For instance, it is to convey the particles or fluid particles or solid particles, well, from one position to the other position, the altitude difference between the inlet and exit, say that is 2 meters. Okay, then well, into this box write 2000. Okay. And then well, the process to apply, if you study it on the video record, well, in the content of this week, I said that how a propeller is created. I think you know the rest. Well, using the same technique can create the well, the threaded part of the Archimedes conveyor or elevator, or in general say that Archimedes screw. Well, you know, we need to use two sketches, okay, two regions. One of them is just a path to use to show in applying sweep process. The other is the cross section at the beginning of the screw, in shape of course. Okay, then well, take a sketch right over the bottom end or top end. The order or site is not so important. Left click, right click, and new sketch. And then in sketch mode, well, depending on the thread height, okay, it is also determined by the designer. Okay, create the necessary sketch. In my mind, this rectangle corresponding to the base of the screw thread at the beginning. So well, projection process, project geometry to have the center of this surface, okay, such that it can snap the cursor, so I can indicate it as a point, and with respect to that point can input the size of the sketch items. Okay, dimensional constraint, I apply project geometry process, and well, thanks to the projected existence of this circle can indicate the center. Okay, dimensional constraint, from the center of this projected boundary to the boundary of the profile, say that distance is equal to 2. Okay, and the thickness of the base of the say thread is totally 4. Okay, depending on the volumetric flow rate, and of course it depends on the speed of rotation. Well, say that designer determined the length of the thread, height of the thread from the center is 120 in this example. Well, no need to have this further extensions, trim. And then yes, this is the profile. Repeat again, this profile is the base of the helical groove at the beginning of the rotor or at the end, depending on the point of view. Okay, and then well, the path, to say that this profile repeats itself along this path, and then define the volume in space as a say helical extension. Well, need to use 3D sketch tool of Inventor. Drop this list and then select start 3D option. And then well, helical curve is the necessary path to have for applying the say sweep process. Well, as the method, I'm going to select in creating the helix, well, revolution and height option. Well, the diameter of the core of the Archimedes screw is, I remember I said 30. Okay, height into this box can write 2000 is the height of the helix. It is actually here the corresponding height of the core of the Archimedes screw. And then how many turns? Well, say that from one end to the other end of the rotor, going to have, for instance, 16 revolutions. Okay, and then, well, this helix extends from where to where? Extends, from the level of the starting cross section of this cylindrical core with a click indicated as center. Okay, and then, well, with one more click, okay, in the vicinity of the other end of the cylindrical core, okay, bring the cursor, then its center point is in highlighting. Say that the axis of the helix extends from the center of the one end of the cylinder to that of the other end. See this highlighting and click. Okay. And then say that apply and can close this dialog box. Okay. Right-handed helix or left-handed helix, well, depending on the case, well, either clicked on this or clicked on that. Well, considering the direction of the rotary motion, it is set by the electrical motor. We'll select this option or that option, right-hand screw or left-hand screw. Okay, and then close this dialog box. And then the rest, apply sweep process. Finish this sketching stage, clicked on finish sketch button, and then the rest, sweep. Apply sweep process. Where is the profile? Zoom in, and show this area, this region as the profile. And then, well, clicked on, make a click into this display. It is just to thereafter indicate the path, indicate the helical groove at any point. Yes. And then the rest is achieved by the software. Okay. Then say OK. Clicked on OK button. Here is the main part of the Archimedes screw. And of course, after having the model of the rotor, then, well, if you're going to complete the assembly in the virtual environment, then be able to have this case, this cap, hinge, then, well, electrical motor, etc. Okay, the rest, of course, depends on your interest. If you're interested with this example, then yes, can create the solid model of such an assembly. But the main part of the assembly, yes, the screw part, and I think I managed to answer the question how the model of such a screw is created. Okay, the rest depends on your interest. Say it is made of, make it solid model, it is made of stainless steel. Okay, or depending on the type of the material, it is to be conveyed or elevated or pumped. Well, select a suitable material for the rotor. Shouldn't chemically react with the material, the other object. It is the material water or any kind of liquid, or say that the material consists of little granular particles. Well, learn the material, learn its physical chemical properties, and then select a suitable material for the rotor to be able to prevent having undesirable chemical reactions. Okay, it is in this example, say that made of stainless steel. Right click assign. Then close this dialog box. Okay, then finish the classwork. Stop recording. Okay, and then say bye bye. Stay healthy. After the break, well, I'm going to in the following record, well, make an introduction saying that well, there are lots of companies today. Okay, they are in cooperation with Autodesk. So, well, if the company is the manufacturer, which manufacturer, for instance, electrical motor, manufactures electrical motors, manufactures some electrical components, electronical components, or mechanical components. Well, you need to use the model of the product of such a company in your project. Yes, shall you create the model of that product? Okay, starting from sketching stage in Inventor, or if of course it is allowed by your teacher, okay, say that you have a project to study, to work as the fulfillment of the course. Okay, in your project, yes, there is an assembly, but one component of the assembly is a commonly used component, for instance, electrical motor. Shall you create the electrical motor starting from sketching stage, or if it has been allowed, just access to the web page of the manufacturer, and over there, yes, you may find the solid model of that component. It has been created in Inventor format. Just download that solid model from the web page of that company and then assemble it at its place in your project in the model of the assembly. Yes, next video record I am going to make an introduction. What is the address of the page to find the hyperlinks to click thereafter for accessing the catalogs of the manufacturers, web page of the manufacturers. These are in cooperation with Autodesk, and then how you can have the model of the solid model of the components, okay, from the web page of such a company. I'm going to make a demonstration on the answer of such questions when after the break, next video record. Okay, bye then, see you.